ቀጣይ የምናየው directional derivatives. Directional derivative is a scalar quantity which is evaluated using this expression. ስለዚህ as a simple example እቺን ጥያቄ እንያት። መጀመሪያ ምን እናደርጋለን? ፈንክሽን እና ፖይንት ተሰጥቶናል and in the direction of a vector ተሰጥቶናል። ስለዚህ first fx እንፈልጋለን። fx is equal to del f by del x which is with respect to x differentiate ስናደርገው it's 3x square ከዛ በኋላ at the point minus 1 to 1 ስለሚል ፖይንቱን እዚህ ውስጥ በመክተት የሆነ ቁጥር እናገኛለን። ስለዚህ 3 times minus 1 square which is equal to 3. fy similarly del f by del y which is equal to 3y square times z. ስለዚህ 3 times 2 square times 1 ማለት ነው ስንት ይመጣል? 12. fz ንም similarly del f by del z which is equal to y cubed which is equal to 8. ስለዚህ the unit vector ነው እዚህ ጋር define እንዳደረግነው the directional derivative is evaluated along the unit vector. ስለዚህ we should find the unit vector of the given vector. the vector በunit vector form አይደለም። ስለዚህ the unit vector of a given vector እንዴት ነው የምናገኘው? it's the vector itself divided by its magnitude. ስለዚህ it's I plus j plus 2k divided by the square root of 6. ስለዚህ du ምን ይሆናል ማለት ነው? 1 over root 6 multiplied by 3 plus 12 times 1 over root 6 again plus 8 times 2 over the square root of 6. ስለዚህ ፋይናል አንሰራችን ስንት ይሆናል ማለት ነው? 31 root 6 rationalize ስናደርገው over 6. በመቀጠል gradient of a function እናያለን። Gradient of a function is a vector quantity which is evaluated using this expression. ስለዚህ simple example እናያለን። መጀመሪያ as usual fxን calculate እናደርጋለን which is the same as del f by del x which is equal to 3x square y minus z square. ስለዚህ በተሰጠን ፖይንት ላይ ኮምፒውት ስናደርገው 3 times 1 square times 2 minus 2 square which is equal to 6 minus 4 which is equal to 2. fy ደግሞ it's del f by del y which is equal to x cubed plus 2yz. This is at the point 1 to the power of 3 times plus 2 times 2 times minus 2 and evaluate scenario it's equal to minus 7. fz ደግሞ with respect to z differentiate ስናደርገው ኤክስፕሬሽናችን y square minus 2xz ይመጣል። this is equal to 2 square minus 2 times 1 times minus 2. this is equal to 8. ስለዚህ our gradient fx in the I, fy in the j, fz in the k ነው የሚመጣው። ስለዚህ gradient is equal to 2 in the I minus 7 in the j plus 8 in the k direction. በዳይሬክሽናል ዴሪቬቲቭ እና በግሬዲየንት መካከል ኦብዘርቨብል የሆነ ሪሌሽንሽፕ አለ። the directional derivative of f of x y z can be computed easily by using the dot product of the gradient and the unit vector along the given function. Remember, it's the unit vector, not the vector given. ቀጣይ የምናየው it's maximum and minimum rates of change. Let's say we have a differentiable function f of x, y, z. Then the direction of maximum increase is the same as the gradient, the direction of the gradient, since it's a vector quantity, while the maximum directional derivative is given by the magnitude of that gradient. And the direction of maximum decrease demo will be the negative when the opposite of the gradient. Minimum directional derivative demo the negative of the magnitude of the gradient ማለት ነው። ስለዚህ በዚህ መሰረት አንድ ሲምፕል የሆነ ኤግዛምፕል እናያለን። for the function find the direction where rate of change is maximum and minimum ይላል። ስለዚህ እዚህ ጋር for simplicity the derivative of the function with respect to x, y እና z ካልኩሌት አድርጌያቸዋለሁ at the point 1, -1 and 0። ስለዚህ the gradient in this case will be 4 in the I minus 3 in the j plus 12 in the k. This is the direction of the maximum rate of change. While the direction of the minimum rate of change demo, the negative of this number, which is minus 4 in the I plus 3 in the j minus 12 in the k. ስለዚህ ወደ ቢ ስንሄድ ደግሞ find the maximum directional derivative and the minimum directional derivative ነው የሚለው። ስለዚህ maximum directional derivative is just the magnitude of the gradient, which is equal to the square root of 16 plus 9 plus 144, which is equal to the square root of 169, which is 13. The minimum directional derivative ደግሞ is the negative of the magnitude, which is minus 13.